Okay, good morning. This morning we are looking at site windflow analysis and design. Can everybody hear me okay? Not too loud? Okay, great. We follow that up in the second session. We're going to start looking at daylight simulation, and then the workshop will follow on with some more advanced concepts in terms of daylight and rendering. Okay, usual lecture rules, please. So, the software we're going to use is Autodesk Flow Design. And this is the link for downloading the software. The software is free, as usual. Now, this is an area of software which has been changing every year. 2 years ago, we did this simulation in Autodesk Vasari. Last year, we were doing it in Project Falcon, another Autodesk product, and we were doing it in the Flow Design plugin for Revit. But it's changed again this year. So in Revit 2016, the Flow Design plugin has come back out again. So we now do this simulation in Autodesk Flow Design as a standalone piece of software. Autodesk Vasari no longer is supported or offered, so we can't do it in Safari anymore. So we do it in Flow Design. It's a bit of a shame in a way, because when it was a plugin for Revit, you could perform the simulation directly in the Revit environment. But equally, it wasn't a very good plugin, and I think that's probably why they've brought it out. Okay. I would say as well, this is probably the weakest piece of software that we use in this module. So it's not a terribly advanced piece of software. It is getting better, but it's still kind of early stages for it. So we still show it to you, we still demonstrate it, and it still gives you an understanding of wind flow. But what you should be clear about is that this is not a kind of very high level computational fluid dynamics software. So I demonstrate the software for performing urban wind flow. So looking at a site and looking at the external wind flow on that site. And for that purpose, it's okay. It's quite reasonable. You should not confuse this with interior ventilation simulation. If you look at this software, you will find people online demonstrating it for internal wind flow and ventilation flow, but it's not really good enough for that. So I'm not suggesting you use it for internal simulation. Okay? If you are interested in internal simulation, then the product you could look at is Autodesk CFD, okay, which again is free. It's a much more advanced package, but it's too much to cover in this module. In this module, we try and cover a whole range of simulation types. If we were to go into Autodesk CFD, we'd need to spend 10 weeks just looking at that. Okay? But equally, I've had some students in previous years who were interested in CFD. They downloaded the software, and they did teach themselves how to use it. Okay. So, Flow Design, this is where you can download the software. And we're going to talk about a few principles in terms of wind flow design. So the first thing to understand is what's called the Beaufort Scale. And the Beaufort Scale is a method of understanding the velocity and the impact of wind. So if we look at the Beaufort Scale here, you've got a grade down the first column from B0 to B10 and a description. So for example, B5 is described as a fresh breeze. Then we've got the corresponding wind speed in meters per second, and that's measured at a height of 10 meters above the ground. So in an urban situation, that would be measured 10 meters up. You might also look at wind velocities at ground level, but in terms of the Beaufort scale, it's measured 10 meters above the ground. The reason being that if you measure wind directly at ground level, then anything such as a car, a low hedge can impact that wind velocity. So we tend to measure it a little bit higher. And then the effects. So for example, B5, fresh breeze, 8.0 to 10.7 metres per second, limit of agreeable wind on land. If we look down at a stronger wind, B8, 17 to 20 metres per second, generally impedes pedestrians, walking difficult to control, huge difficulty with balance in gusts. So it's a really good method of understanding the wind. Okay, and as you see at the bottom here, wind speeds measured at 10 metres above the ground are reduced to about 75% at head height. So if you were measuring that wind at sort of head height, you could expect that to be 75% of the measurement at 10 metres above the ground. Okay. Now, in this example I've given you, the wind speed is given in metres per second. If you Google Beaufort Scale, you'll find lots of other charts using kilometres per hour as well. I tend to prefer metres per second. Okay. You'll also find lots of other scales which have little images, little pictures, which are all, all fine. Now, this is an extract from a guide that I've given you the link to, and this is how, in this particular city, how they are applying the Beaufort Scale. So what they're looking at is, for different activities in the city, how would we judge the wind? So for example, if we go back, let's look at our B5. Fresh breeze, 8 to 10 metres per second, limit of agreeable wind on land. So, in this design guidance, if you were designing a park or an entrance, B5 would be considered tolerable. So it would be considered kind of acceptable. Okay? If you went to the next velocity, B6, that would be considered unpleasant. And if you went up to B8, that would be considered dangerous. Now, for a different activity, if we look at here, street cafes, for example, then a tolerable wind level would only be considered B3. And if we go back to our scale, B3, 3.4 to 5.4 metres per second. So in other words, what they're saying is, for a cafe, you need much more shelter from the wind for that to be acceptable. Because I guess if you're sat in a cafe and the wind's sort of blowing everything around and blowing your clothing, you would probably go inside. So important to understand that depending on the activity, you can have more or less wind. So for example, if you're walking, tolerable would be B6. If we go back, B6, a strong breeze, 10 to 13 metres per second. So umbrellas used with difficulty, force of the wind felt on the body, and in this guidance that would be considered tolerable. So in other words, if you're walking about a city and there's quite a strong wind, but you're walking, you would think, well, that's acceptable. And you're walking along the street and, it is a windy day. But it's sort of different. If you're sat, for example, in a park or a plaza which has been designed, experiencing that level of wind, you would consider it unacceptable because you're perhaps sat down, it's a space which has been specifically designed, so it should have been addressed. So really important to understand those different levels of tolerance. For our case study assessment here, based down on the forecourt, think about the activities. So we've got, down there, we've got walking. So on parts of that plaza, people will just be walking. So people will be walking past the Arts Tower, heading to the Students' Union. So they're just walking. So they might consider B6 tolerable. If you're just sort of strolling around, you would only consider B5 tolerable. If you're on a kind of plaza, so if you're, for example, sat in the plaza downstairs, you go out there to have your lunch, for example, you'd only consider B4 to be tolerable. And if there was an outdoor cafe, you would only consider B3 to be tolerable. Now, if you look at the bottom row, acceptable if speed occurs less than. So, quite important here. This level of wind speed, B8, which is gale, 17 to 20 metres per second, would be considered acceptable if it occurred less than once a year. So less than once a year is actually 0, but I think it means probably once a year. So in other words, once a year you would probably accept if there was some really strong winds. Okay. If that happened every month, we would not find it acceptable. Then if we move down the scale, if we go, for example, to our tolerable level of wind speed, we'll find that acceptable if it occurs, let's say, less than once a week. So once a week or thereabouts, we'd find it acceptable. We'd not find it acceptable if every time you walked out the front door of the Arts Tower, there was a huge wind blowing you over. Okay? Now, what you might not have seen yet, but you will, that little gap between the Arts Tower and the library, because of the funneling effect, have you seen that? You get some very high wind velocities through there, and it's a real problem actually. And you know, people have been knocked over. Many architectural students have walked down the street with their lovely architectural models, and their models have gone off into the sky. And you know, and that's clearly not acceptable. It's even dangerous. And probably what we're getting there, because of the wind funneling effect, we're probably in the sort of B8 to B9 level. But it's probably happening, I don't know, 4, 5, 6 times a year. So that's, you know, that's something that's clearly a problem. Okay, now I'm not going to make you experts in terms of wind design, but I just want to give you some familiarity with the principles. Now, you should be clear, there are experts out there, and they're called aerodynamicists. Now, these are people who have studied Windflow, and they, you know, they are the real experts. Now, in architectural practice, as an architect, as a designer, I think it's great to have an understanding, and it's great to do some early stage design, but just bear in mind that there are experts out there as well. Okay, let's move on. This was some further guidance this is from Wellington City Council, which I thought was very, very useful guidance. Now, what they're saying here is, depending on the existing wind speed, what will we consider acceptable in a new development? So if the wind is, I think this is supposed to say 0 to 10 in here. I need to change that. If the existing wind is in the 0 to 10 metres per second, and the wind speeds are going above that 10 metres per second, sorry, this should say 0 to 15 metres per second, then in this city, the designers need to reduce that down to 10 metres per second. If the existing wind speed was measured as 15 metres per second on site, and as a result of the development, so as a result of the building, if that wind speed was being pushed above 15 metres per second, this is what the designers would have to do. They would either have to reduce it to 15 metres per second, or this statement at the end, overall impact is to be no more than existing. So in other words, what they're saying is, if you're experiencing winds above 15 metres per second, then your design must not make that worse, because that's quite high wind velocity. And as a designer there, you'd have to make sure that your design limited to 15 meters per second. And it's the same. We've got 15 to 18 here. If the existing wind speed is 15 to 18 meters per second, and your design is creating a wind exceeding 15 meters per second, you actually have to reduce it to 15 meters per second. So you actually have to make the wind velocity lower than the existing. If it's above 18 meters per second, you have to just make sure that you don't make it any worse. So you have to reduce it. In fact, you have to reduce it to 18 meters per second. So what this guidance is saying is high wind speeds can be quite dangerous, can be quite unacceptable in a city environment. So as a designer, you need to control those wind speeds. And this is the kind of guidance that you can use when you're assessing your site at the bottom of the Arts Tower here. Okay. Methodology. You need to understand your site wind conditions. And when Windflow was a plugin for Revit, this used to be all done inside Revit, but now you have to do it in a different way. So you need to understand the wind of your site. Two possible ways. You can create a windrows from your Revit energy analysis, which we've already demonstrated. So this is a typical windrows. This is the windrows for a whole year. Or you may extract that data for specific months of the year. You can also create a wind wheel in Climate Consultant, which is a piece of software that I've demonstrated to some of the students. And that looks like this. So you've got two options there. Both will give you the same results, but just depends on your preference, really. Okay, so if we just have a little look at, I'll go back to the Revit windrows. Just to understand the windrows a little bit more. So in this particular windrows, the colours relate to the wind speed. The length of the bar relates to the percentage of the year where you experience those wind speeds. And the direction is the direction that the wind comes from. So for example, if we look at this bar down here, we're getting wind speeds in that dark blue, 57 kilometers per hour, but it's a very narrow dark blue bar, indicating it's for a very, very small percentage. If you look at this light blue, which is the 21 to 29, this is kilometers per hour. The Climate Consultant one uses meters per second. So in that band, you're getting that for quite a much larger percentage of the year. Okay. These combined metrics indicate where the wind is coming from. If we look at the Climate Consultant, if we look at this is a specific month, in Climate Consultant, this middle part of the chart, the key is here. What you've got, the spiky orange triangle, is the average wind speed. And this is in meters per second. The dark orange is the maximum wind speed, and the yellow is the minimum. So for example, if we look here, see where my mouse is there, the light orange spike, the average, is saying that the average wind is 6 meters per second from this direction. The maximum measured wind is 12 meters per second. So thinking back to our Beaufort scale, anything below 10 meters per second was generally considered quite acceptable. So if you were interrogating a site using this windrows, you might look at this and say, well, we don't need to worry too much about these velocities below 10 meters per second, but we're probably more concerned with these peak velocities. So if you look at these darker orange, we're getting velocities in the sort of 14 up to 16 meters per second. So quite fast wind velocities. In Climate Consultant, the yellow bar here is then the percentage of hours that you're experiencing the wind from these directions. Okay. Now, in terms of methodology, with the wind, you have to sample throughout the year. So the wind, if we go back, the wind comes from all sorts of directions. So you can't do a single simulation. You have to look at your wind direction, look at your windrows, and decide where you're going to test. So if I go back to this is the whole year for Sheffield, and what you see is the winds tend to be stronger in the south, southwest, and the west, but you get wind from all directions all year round, effectively. Some sites you get a much more directional wind. So probably, if this was your site, I think you might quite reasonably decide that you're going to test from a range of directions, because the wind comes from all over. Okay. Look for the highest velocities. We're more concerned with the high velocities. Look for the most frequent directions. In Sheffield it comes from all around, but some cities have a much more directional wind. And then you don't need to test the directions that the wind doesn't come from. Think about critical dimensions. For example, the direction of the wind, for example, facing your entrance to your building. That could be a really critical direction. Are there any existing issues on site? So, before you look at your new building, conduct a simulation of the empty site and try and understand if there are any high wind velocities being created. Obviously, you can go out and have a look as well if you have access to the site. Then consider the impact of your new buildings on the site. So you have the existing condition. When you add your new building, does it make it better or worse? Really important. You can't be making that site worse. Are there any site improvements you might want to consider? Would you consider perhaps adding some planting or some walls to kind of shield the existing area? So if we take this site, for example, we've got that problem between the library and the arts tower. Is there anything you could do in your design to improve that? Location and design of outdoor space. If you've got any outdoor seating, then is that affected by wind? Do you need to consider its position? Do you need to consider some protection? And planting. Planting is actually very effective as a wind buffer because it tends to slow the wind down. Rather than just deflecting it, it tends to absorb some of the wind's energy. So that can be very effective. The building level. So, how high is your building? That can have an impact on the wind. The entrance design is important. Ventilation implications. Now, we're not looking at this in detail, but you can test, are there any areas on your site where you're perhaps getting very low wind velocities or very high wind velocities, and they may indicate that they're not very good positions for opening windows. Building size, shape, orientation, all important factors. Okay, a few references. Wind Design Guide you can download here. And Micro Wind Turbines in Urban Environments is another useful document looking at how you might want to harness the wind energy in an urban condition. This one you can download from CIS through this link. These slides are on Mole, so you can get these links from Mole. Okay, let's move into the software. And we'll have to go reasonably quickly. So, first thing, how do you get your information from Revit into flow design? So I've opened a Revit model here, and I'm going to show you what I think is the best way to get the information. There is another way, but I think this is better. So first thing is prepare your model. So there's my site model. This is still my incomplete site model. Your site models will be better than this. Let's get that model ready. Whatever you see on screen is what you will export into Flow Design. I find it's best if you switch your section box on. I'll go into a top view, select my section box here, and I'm going to just crop my site topography a little bit. Okay, like that. Go back into a 3D view. And that now gives the edge of my site model a thickness, which will be brought into Flow Design. If you don't do that, your site model just tends to come as a thin surface. Okay. Now, firstly, this is how I'm not performing the export. You can export an STL. An STL is a file format which we use for 3D printing. I've already given you the link to the STL plugin. That is one way of exporting, but it's not my preferred method because it does not bring in the topography. So don't do that, I would suggest. Instead, click on your Revit button, Export, FBX. So we have to make an export as an FBX file. Okay, I'll just put that on my desktop. I'll just call that option B. Okay, save that. That's done. So I'm now going to exit Revit just to save on a bit of processing power in my computer. And we'll go into Flow Design. So when you open Flow Design, this is what it looks like. You've got a few demonstration models or import. So I'm going to click on import, find that document on my desktop. Oh, that one there, option B. Okay. Just give that a moment. Now, Flow Design it's like a wind tunnel. So it's just like a digital wind tunnel. If you've ever seen a wind tunnel, this is a piece of equipment that we used to use quite a lot before we had digital simulation. In a wind tunnel, you would put a physical model into a lab and you would blow air at it, and then you'd put smoke in and coloured dyes, and you'd watch the effect of the wind. Excuse me. Flow Design is the equivalent of a wind tunnel, but obviously you can do this in your own computer. You don't need a model, you don't need a wind tunnel lab. Okay, the model has been brought in. First of all, we need to get the orientation correct. It always brings it in with for some reason, with a slightly wrong orientation. Click on your orientation, and it's the X angle that we need to change by 90 degrees. And that will just change the model. Now, in Flow Design, in the previous versions, you could change your wind direction. In Flow Design, they've done it a different way. In Flow Design, you have to change your model direction. Okay, so in order to change the direction of the wind, you have to again go into orientation and change these angles. So if you change your Y angle here, okay. I mean, it doesn't really make any difference. It just means that it's a bit more like a physical wind model where your wind always comes from the same direction. You have to change your site around. Okay. Okay, so we're in there. Now, it's a bit faint, but you've got some controls over here. Okay, and you've got a Viewcube, same as in Revit. So same idea, if you click and drag your Viewcube, you can drag your model. Okay, you can drag your view, sorry. Equally, you can use the controls over there. Over here, you've got your usual sort of orbit, pivot tools that you'd be familiar with. When you're in that, when you've activated that, you have to re-click back on the button over here to deactivate it. Okay. Then also you've got your normal mouse controls, but slightly frustrating, it doesn't use exactly the same controls as Revit. So panning is slightly different, it's the left mouse. And also, the reason I don't use my mouse in Flow Design, what tends to happen, you end up with your model on its side because it does not constrain it to a vertical axis, which is quite frustrating. So I tend to navigate my model, I tend to either use the Viewcube up here, because that will always keep your verticals vertical, okay, or use the orbit tool, the pivot tool, sorry, around here. Okay. Right, I'm going to show you some of the tools in Flow Design. It's definitely a piece of software that you will benefit from having a little, a bit of practice yourself. Okay, let's go through some of the controls. So your first option, File, lets you save an image or save a video. So save image. I'll just put this on the desktop. Okay, that will just save. I just view that. So it will just save out an image of what was on the screen. Okay. So it just gives you a screenshot of the simulation, just exactly what you had on the screen. Takes away the toolbars. Okay. So that's all fairly straightforward. Save video, you can have a play with that yourself. Save video, it just exports a video of the wind simulation, basically. You've got a little lighting, a little light box there. I just tend to leave it on. You've got various different color schemes you can use. You can find which you prefer. That one's quite a good one. And you've got contours and you've got banding. And I actually find putting the banding and the contours on is quite helpful. This is your key. Top left there is your key, which is a velocity in meters per second. And I just find by putting the banding on, it's a bit easier to understand what these colours mean. So for example, that yellow is 14 meters per second. This dark blue is sort of 0 to 1 meters per second. Okay. So that's okay. So let's just go through some of these tools. So that was all about our different color schemes. Next one, dark or light environment. It's just a graphic visibility thing. I don't know, I think the dark one works quite well. Okay, but you can just toggle between those. I'll leave it on dark, I think. Then we've got, these are our toolbars. A useful one here is tunnel bounds. So if we click on tunnel bounds and zoom out a little bit, what this is showing us is what size simulation do we need? Now, there's not a lot of point having a simulation which is much larger than your site. So in this instance, I would probably drag these arrows here and make my simulation a little bit smaller. It takes a little while to recalculate. Okay. It will just save on a bit of processing power and a bit of speed if you make that simulation a bit smaller. Okay, you don't really have to. I've not found flow design crashes very often. The old version used to be terrible. It used to crash all the time. You had to, when you were using it, you had to keep saving images because the thing would just crash before you could get anywhere. But seems to be better. And I mean, I'm not exactly using it on a high-powered computer. This has got an i7 chip in it. Okay, so I'm just making my simulation area a bit smaller there. Okay, that's that. If we go back in here, I'm going to turn my tunnel bounds back off. Okay, so there's our simulation. You've got a few other things in here. You've got a drag plot, which I don't... The drag plot is more if you're testing like a sort of vehicle or an aeroplane, which, probably not so relevant for us. Switch that off. Okay, let's go through some of the other tools. But I'm going to firstly go into the last one. And this one is you dictate whether you want to slice in a vertical or a horizontal plane. So if I go into a top view here, zoom in a bit, what I've done there, just pan that a little bit, is I've changed that into a top view, a sort of horizontal slice. So you can see now our buildings are peeking through that, and it's simulating the flow of the wind. If I just zoom out a little bit here. Okay. And what you can do by simply selecting this little ball here, you can drag that plane and set it at whatever height you want. Okay? And that will re-simulate the wind. Now, I'll leave it up to you to decide, how you want to create this for your report, whether you want to create these views in a plan view, a three-dimensional view, that's up to you. But if we just, for example, look at this simulation here, I just pan a little bit more, the kind of thing you might observe from here is we've got a wind flow coming across here, and these sort of bright yellow areas, or bright red areas, are places on that site where the wind velocity is being increased. So the impact of these buildings is creating these faster areas of wind speed, which could be something as a designer that you're perhaps slightly concerned about. Okay, so just going to go through some of the other settings. So next one, the first one, the simulation, you have a simulation resolution. So how detailed do you want the simulation? At the moment, it's set on on 100%, which is quite low setting, but gives you quite reasonable results. If you had a more detailed model, you can set that to a higher level. Your wind tunnel settings. Now this is really important. Your wind speed. So what speed do you want to test? Now if we go back, oh well, I won't open it now. If you imagine your windrows for your site, the kind of typical wind speeds you might want to test are, you might want to test, let's say, the average wind speed, which, as we saw, was about 6 meters per second. So if we go back in here, let's set that to 6 meters per second, and we now simulate a slower wind speed. You have to give the simulation a moment to recalculate. So we're now simulating a much slower wind speed, a sort of average wind speed for this site. What you might also want to do is simulate the real peak wind speeds. So particularly on this site, you notice the simulation is now working its way through. You have to give it a few moments to push that wind through. And now, because we're starting with a much slower wind speed, we're not getting such high wind velocities. Okay, what you have to watch for as well is the colour key does change. Okay, so what it does is yellow is always your highest wind speed, blue is your lowest. It's not fixed scale. Okay, you might also want to simulate your peak velocities. So if we put that wind up to 18 meters per second, so we're now simulating a really sort of high storm, and now we can look at the impact of that. Okay, so I'm just going to put that back down to something more reasonable. Let's put that back down to 10. Orientation. As we mentioned before, the wind is propagated from this direction in flow design. So if you want to simulate your model in another the wind in another direction, you need to spin your site around. Just give it a moment. So now we are simulating the wind coming from a different direction on our site. Okay, so that's the orientation. 2D or 3D, I'll come back to that. We can either show wind velocity, which is probably more useful for us, or pressure, so the wind pressure on that site. I think for what we're doing, velocity is more useful. Drag plot, I think you can ignore, because that, again, is about testing vehicles, cars, so on. So I don't think you need to worry about that. Okay, plane or flow lines. If you put flow lines on, as you see, we no longer get that kind of colour-coded plane, but we get these flows. And if you kind of look quite closely, you get some turbulence. So in some respects, it can be easier to understand those areas of turbulence. I'll just zoom in a bit there. Okay. Once you activate flow lines, you get further settings. Tubes, smoke, particles, probably lines is easier. And you've got settings for your lines. So how many do you want? I mean, that's, can be quite useful, because bear in mind, you've still got your velocity color-coded here. And the benefit of the lines is you get to see that sort of turbulent effect. So if you look here, for example, we're in very low velocity and the wind is actually kind of blowing backwards and it's turbulent. whereas here the wind's flowing very fast past our buildings. We can slow down the visual effect of those lines, speed them up. Size, you can make them thicker, thinner. Okay. Length. You can control the length of them. Okay. So that's controlling the graphic interface. Usual, you can save image. So this should, desktop, this should save that frozen image. Let's just go and check that. Where have I put it? There. So this is just a frozen image. It's taking a long time. Ooh. All right, that's just my computer for some reason. But there's the there's the image that we've just exported anyway. Okay, so that was flow lines or plane. Lines, settings. Okay. And again, the top view, side view, you can change. So we're now viewing those flow lines in a side view. Okay. Now again, I don't think, I wouldn't get too concerned about a kind of high level wind flow around your building. I'm not really asking you to consider, what's the implication of that wind velocity flowing over the top of your building. That's a little bit high level. But what you might use the side view for is to perhaps look at, is there anything, are there any concerns on your exterior spaces? Perhaps if you're designing some outside spaces, for example, you might look to see if there are any real kind of problem areas in that side view. Normally, the top view is the more useful. Oh, sorry, because we flipped the we flipped the direction. They call it differently. Okay, I'm going to put that back into a plane. Says our plane view again. Now there is also, so if we change to simulation mode, let's give that a second, and we'll put it back on flow lines. You get a much more complex three-dimensional simulation. Now, personally, I find it difficult to work with because there's too much information in a way to understand. It also slows your computer down massively. So I normally just work in the 2D mode, which I think is a better way of working, actually. If it gets there, you will see it will perform a simulation in a kind of three-dimensional environment. But I'm not sure if it's going to do it. Yeah. So, okay. So you see, it's performing that simulation now. And we can customize how it looks. I guess it's kind of, you know, like what you might have seen in an old-fashioned wind tunnel. Okay, I've just slowed it down a bit there. So it's difficult, you know, it's difficult to understand, I think, because you're just seeing everything at the same time rather than a slice. But you know, you can have a look. Yeah, you know, it's simulating the entire Windflow simulation in one go. You might find you can make that work for you. Okay. Oops. Particles. I'm going to put that back to 2D. Okay, we're going to stop now and have a break. So I've shown you the basics of the software. It's not a terribly complex software. I think the key thing is for you to think about how you might use it for your assignment to get into some early stage simulation of this site. Okay? And I think, you know, that's what it is useful for. You can start to identify possible problem areas. I think the way you should imagine it is, imagine that you're providing some early stage guidance on this design. But before this building is built, finally, let's assume that there will be a professional consultant aerodynamicist involved, and they will perform a more complex simulation. And also they have design insurance, because as an architect, you wouldn't normally advise on kind of Windflow design. So imagine that you're maybe going to identify some problem areas, propose some solutions as an outline early stage design, and then that kind of expert consultant later on would do some more complex simulation. Okay. Any questions before we have a break? Yeah. Yeah, let me open the slides again. So just bear with me a second. Yeah, so you need to understand how the wind is working on your site. I'm just going to open the windrows again. Well, I'll show you that on the windrows. People tend to talk about the prevailing wind is from the southwest, but that's one of those slightly imprecise terms. So if I just open this. So this is the Sheffield. This is the Sheffield windrows in Climate Consultant. Now, the bar around the outside is the frequency of the wind. So we do get most of our wind round here, but as you can see, it's not all kind of in one place. It's not in one direction. And then if you look at the wind speeds, the wind tends to be stronger around here, but again, it comes from lots of directions. So for this site, you really would have to test it in many directions, I think, because you can't say that the wind comes from the southwest. If we go back one, to this site, I'm not quite sure which site this was. We're getting a much more prevalent wind in this direction. I think this might be, I'm not sure where this was from, this one. But you know, in this, if you were simulating for this location, then yeah, you could probably simulate the wind from the west, simulate it from the southwest, probably, maybe simulate it from the south as well. And there's probably not much point simulating it from these directions. Maybe you would only take three directions. Yeah, I mean, it also depends on your site. Because of that wind funneling effect, where the wind gets blown between buildings, if your site has some particular sort of narrow points between buildings, you might say, right, let's point the wind at that narrow point. Let's see what happens. You might look at your building entrance and say, let's point the wind at the building entrance, and you know, see what we're getting from that. Okay, so that's why I said you have to kind of sample. You need to look at your wind conditions, look at your site, and you have to perform multiple samples. But it is, of course, quite quick to do that. Okay.
What about wind speed?
Well, wind speed, what I was suggesting is, if we go to the climate consultant example, I think what would be quite reasonable would be to take the average wind speed, which for Sheffield here, for our site, is this orange, which would indicate a sort of average wind speed of about maybe 5 or 6 meters per second. That's a kind of typical average wind speed. But equally, I think you would want to simulate some of these higher wind speeds, because when you look at this, it's not so uncommon to get these higher wind speeds. So I think it would be worth, you know, particularly for this site where we know we've got some wind issues, I think I would simulate some of those higher wind speeds, because you would be concerned if we had a very strong wind and we know that people are getting blown over down there, we'd be concerned to make sure that our building doesn't make it any worse.